So we'll start the session with the discussion of a pop quiz, MCQs related to the topic. If you have any doubt, you can mention your doubts. Question number one, any doubt? Question one. Any doubt in question one? Question two, any doubt? Question two. Question one, okay. In question one, a guitar string vibrates to create a sound. The speed of the wave in a guitar string is always 440 meters per second. The vibrating string creates a sound wave that moves in the air, and the speed of the sound in air is 330 meters per second. Which graph shows the variation of the frequency and the wavelength in the string? So as we know, the speed is constant, and according to a wave equation, V equals F lambda. Or I can also say V over lambda is equals to F. If the speed is constant, speed is not changing. So what it shows a relation between the wavelength and the frequency that is inversely proportional. If the wavelength is decreasing, the frequency will increase. Or if the frequency is decreasing, the wavelength will increase. And when two quantities are directly inversely proportional, what will be the graph between them? If we sketch a graph between the wavelength and the frequency, so the graph between them will be a curve. That is the relation between, that's how the graphical representation of the two inversely proportional quantities. So it should be a curve. It cannot be a straight line. So it cannot be A or B. We are left with C and D. Then the variation, as in the question, they already mentioned that the wave in a string is 440. Like if the wave is produced in a string, the speed of the wave is 440 meters per second. Means the product of the frequency and the wavelength is 440. Where the wave which is produced in air, it is having a speed of 330 meters per second. So the product of frequency and the wavelength is 330. So in air, the product should be less, like 330, and where in string, the product should be 440. So option C represent, like it is showing that two quantities are inversely proportional, and in air, the product is less. That's why the graph for frequency and wavelength is below for air, and a graph for a string is above, because it shows a higher value of a frequency, like a product of frequency and a wavelength will be higher. When you multiply them, it will give a large value as compared to when you multiply these two. Is it clear? Question one. Question two, any doubt? Question three, any doubt? Question two and three. In question two, the graph shows a variation with time for a displacement of the two waves x and y. Wave x has a frequency f and the amplitude a. So this is a wave x, as they already specified. What is the frequency and the amplitude of a y? If we want to compare the frequency, we can compare the time periods, because the relation in the time period and frequency is inverse. So the time to complete one vibration, this is wave y. If I draw this wave y, this is wave y. So if you compare the wave x and y, which is having a longer time period, the longer time period for wave y, like it's taking much longer time to complete its oscillation as compared to that of wave x. Or it is approximately double. How it is double? Because when x is completing two oscillations or two complete cycles, Y just completed one cycle. So it means the time period of Y is twice of time period of X, according to the figure. And what is the relation? If the time period is double, what about the frequency? Because the frequency relation is inverse. If a wave is having a twice, but what about the frequency? The frequency relation of a Y. So frequency of a Y will be frequency of X divided by 2, because the time period and the frequency are inversely proportional. So if the time period is double, the frequency will be half. So the frequency of a Y will be half of the frequency of X. So it means it will be F by 2. What about the amplitude? Amplitude is comparison of the height. When you compare how many boxes it cover, 1, 2, 3, 4, 5 boxes are there. And when you measure the amplitude of this one, it's 10 boxes. So what this give an indication? It give an indication that the amplitude of the Y is twice. The amplitude of the Y is twice the amplitude of X. So amplitude is twice where frequency is half, because the time period was double. So we compare these, it matches with option B. So B will be the right answer for this. Next is question 3. A loudspeaker emits a sound wave into a tube initially full of water. So this is a loudspeaker is there. The tube is complete full of water. Then a tap at the bottom of the tube is open so that the water slowly leaves the tube. The water is removed from the tube. For some length of air column in the tube, the sound heard is much louder. The first loud sound is heard when the air column of a tube is a length x. So what does it mean if I draw this? Let's say this is position x, and we heard a loud sound. So when we heard the first, because what it is producing, it will produce a standing waves. How it produces a standing wave? That the sound from a loudspeaker strike the water surface and it bounce back. When two waves which are traveling in opposite direction, they will give rise to a standing wave. So when we heard the first loud sound, recorded a first loud sound, so it means this is the first harmonic. We will have a antinode on the open end and we'll have a node at the close end. So this will be the pattern like this. This is the first pattern. When the next time the loud sound is heard when the air column is in the tube length x, length y. So there is length y. This is length x. Now what is the pattern it is produced? Because we heard a next harmonic, the first harmonic. This is a close. This is refers to a closed pipe. Why it refers to closed pipe? Because one side, why we refer this as a closed pipe? Because one side it is having open end and another side it's a closed end, because water is acting like a water is reflecting the sound waves. So it's an example of a closed pipe. So we'll have antinode, we'll have node, antinode, and node will be there. And what will the pattern produced? So this will be the pattern produced. So this is y, the displacement, and this is x. If you want to work out the wavelength of a source, so what we simply do, we just take a difference between the first harmonic, like consecutive harmonics, we take a difference. Like what is this in terms of the wavelength? What is this distance in terms of the wavelength? This is quarter of the wavelength, because the distance between a node and antinode is lambda by 4. And what about this one? In terms of the distance between the two successive note, it is half of wavelength, and this is a quarter of a wavelength. Like this part is a quarter of the wavelength, and this part is a half of wavelength. So when we sum them, it will be 3/4 of the wavelength. So whenever we need the wavelength of a wave, we just subtract the two parts. So the wavelength should be equals to y minus x, the spacing, the difference between them, and that is equivalent to what? That is equivalent to 3 lambda by 4 minus lambda by 4. When we simplify y minus x, so 4 is an LCM, so 3 lambda minus 2 lambda minus lambda, that is equals to 2 lambda. When we further simplify, lambda by 2 is y minus x. 2 is divided, other side multiplied, so 2y minus x is equals to 1 wavelength. So wavelength of the wave is equals to twice of y minus x. So for this question, these type of a question, it's a repeated type of a question. Whenever you need the source wavelength, okay? Whenever a question is there, find the source wavelength. So first you will find the pattern for the first, then you find the pattern for the second and subtract them to know the actual wavelength of a wave. Because when we subtract the two harmonics, we know what is the source wavelength. So when we subtract the two, because this total is y and this one is x, so how much is this distance which has moved? So this is y minus x. So y minus x is equals to, so y minus x is equals to the wavelength of the source and the difference in the wavelength. So the difference in the wavelength, y minus x is actually equals to what? It is equals to lambda by 4 when we subtract. So lambda by 4 is y minus x. Lambda is equals to twice of y minus x. Is it clear, this one? So this is always the case. This is a repeated question. There's another similar question is there. The same pop quiz you will find. I will solve that. So same way, we find the length of the first harmonic in terms of wavelength, length of the second harmonic in terms of wavelength, and we subtract to know the wavelength of the original wave or the source wave. Question 4, any doubt? No doubt. Question 5, any doubt? Actually, question 5 is related to memorizing the wavelengths, the order of the wavelength. You have to learn this for especially for electromagnetic spectrum. You have to learn the order of the wavelength. So in the question, they mentioned the graph shows the intensity of an electromagnetic radiation emitted from a distant star varies with the wavelength. In which region of the electromagnetic spectrum is a radiation of a greatest intensity? So what actually you have to do? You have to draw, this is the maximum intensity and you have to draw a line here. So which one it matches with? It is about 175 in general, like estimation is there 175 into 10 power minus 9 meter. Then what you have to do, you have to check which one it match with the order. You have, it cannot be visible because visible is from 400 nanometer. The visible is from 400 nanometer to 700 nanometer. That is the range of a visible. And it's a shorter wavelength. So after visible, we have UV, ultraviolet is there, and then X-ray is there. So when you check the range, you will find it lies in the range of UV, 175 nanometer. So this is totally related to memorizing the order of the electromagnetic radiation. You have to learn that. Question 6, any doubt? Question 6 or 7, any doubt? Question 6, 7, 8. Okay. Which statement concerning a stationary wave? So, how a stationary wave is formed? When two progressive waves travel in the opposite directions, they give rise to a standing wave. In a standing wave, we'll have a nodes and antinodes. What nodes are representing? Nodes are representing the minimum displacement point, and antinodes are representing the maximum displacement points. And how the particles are vibrating in adjacent nodes, like particles, adjacent particles of the nodes are vibrating, antiphase are there. So if this particle is going down, this will go up. This particle will go down. But all these particles here will move up, all these particles will move down. Same thing, all these particles are going down. This is the pattern of the motion of the particles in a standing wave. So the question is, which one is explain? All particles between the two adjacent nodes oscillate in phase. What does it mean? Like if we have adjacent node, say this is a standing wave, and we have the adjacent node, like this is one node, and this is the adjacent node. So all the particles between the adjacent nodes oscillate in phase. That is true, because these all particles are going down, other will move up, then all will move down. But between the adjacent node, like example, if I take this and this as a node, all particles are going down. If I take second and third node, all particles are going up. If I take third and the fourth node, all particles are going down. So between the adjacent node, all the particles are in phase. That's why it matches with option A. What about the other options? The amplitude of a stationary wave is equals to amplitude of one wave is created. No, that's not the case. The amplitude of a stationary wave is not constant. It is changing. At antinode, it is maximum. And what does it mean? What they're saying that when the waves are combining with each other, the amplitude of a stationary wave is equals to amplitude of the waves which are creating. That is not the case. It will be a sum or the difference of the amplitudes. The wavelength of a stationary wave is equals to separation of the two adjacent nodes. No. The distance between the two adjacent nodes is equal to what? It is equals to half of the wavelength. So the spacing between the two adjacent nodes is equals to lambda by 2, not equals to wavelength. And there is no displacement of the particles at antinode at any time. That is not the case. This should be for nodes. When nodes are produced, the particles are not moving, because for the antinodes, what will happen? The group of the particle first they are up, and then the next moment that group of a particle will be down. So nodes, the particles are not moving. Antinodes, the particles are moving. Particles are moving. First, they are going down to the other extreme, then going back to up. Is it clear? Question 6. Question 7. Which waves would best demonstrate the diffraction through a doorway? The door gap, the width of a door is usually like in the range or order of 1.5 meter. And that matches with the wavelength of the sound wave which we produce. Like this is about 1.5 meter, and the sound which we normally produce is also in the same range. So when the door gap matches with the wavelength, maximum diffraction happen. So which wave would best demonstrate the diffraction? Diffraction, for a demonstration of a diffraction, the wavelength and the gap size should be same or same order. So it matches with the sound. That's why we write A as a correct answer for this. So the sound waves, in question 8, two loudspeakers are placed near to each other and facing in the same direction. A microphone connected to an oscilloscope is moved. It's like a diffraction pattern we observe, the waves from here and waves from here. If they're constructive interference, If they have a constructive interference, the path difference will be zero wavelength, maxima we'll observe. Then if it is a destructive interference, path difference will be half of the wavelength. Then again a constructive interference will observe a maxima. Then we'll have a minima, maxima, and so on. So which statement about the waves emitted from a loudspeaker is not a necessary condition for a microphone to detect a fixed points where there's no sound. Whenever we want to observe the interference, it's not about waves should be in phase, it's about waves should be coherent. There's a big difference between a coherent and the in phase. In phase means that every time, like in phase means like if it is emitting out crest, this is also emitting out crest. That means in phase. But to observe the interference pattern, we can have the two waves. One is emitting out trough, the other is emitting out crest, but they should be coherent. When we say coherent, that every time the same phase is coming out. So we can observe the interference pattern clearly. Otherwise, what is happening? Let's say this source is emitting out crest. Next moment, this is emitting out crest. Next moment, it is emitting out trough. Next moment, it is emitting out crest. So it means it will be hard to recognize a single point where there is a constructive or a destructive interference. So we don't want the two waves to be in phase. We want them to be coherent. So there's a difference between, we want a same phase. We don't need same phase, but we need constant phase. There's a difference between a same phase and a constant phase. Same phase means that if one wave is emitting out crest, the other should also emit out crest. That means same phase. But a constant phase relation means every time, if this is emitting out trough, this is also emitting out trough. If this is emitting out crest, this is emitting out crest. Or every time if this is emitting out crest, the other is emitting out trough. That we call a constant phase relation. So we don't want them to be in phase, we want a constant phase. So the wave must be emitted from have a similar amplitude. Yeah, that is the right thing. Like A is the right answer, but why B, we need them to have a same amplitude. If the amplitude of one wave is larger than the other, so it will be hard to observe the interference pattern. They should have a same frequency and the same wavelength. We need that, but we want a constant phase relation. Constant phase relation, but not in phase. In phase, they might be in phase, they might be anti-phase, but what we want is a constant phase relation. If one wave is emitting out crest, the other should emit out, if it is emitting out trough, so every time the relation should be crest and trough. Or if one wave is emitting out crest and another is also emitting out crest, so every time there should be crest from the two waves, two sources, I mean. That means the constant phase relation. Question 9, any doubts? Question 9, a parallel beam of a light passes through a diffraction grating. The orange light of a wavelength 600 nanometer is a fourth order diffraction maxima is there, which coincide with the blue light fifth order maxima. So we have a grating element. So this is a grating element. Grating element means when we have many openings are there on a slit, we call that as a grating element. And we have the screen. So first there's an orange light. So let's say this is a central maxima. So we have fourth order maxima for orange. Like this is n is equals to 0 and this is n is equals to 4 for, and this angle is theta for orange. Then there's also a blue light, and the fifth order for blue light, the same region, which maxima we observe? We observe a fifth order maxima. So n is equals to 5. The theta for because it's the same place we are getting, so the theta for the blue light will be same as the theta for the orange light. The order of the image is different because Blue is having a, when you compare the wavelength, it's having a shorter wavelength. Now, we have the formula in the diffraction grating. The formula is d sine theta is equals to n lambda. When I write for a d and sine theta is same for both. Why? Because d is the spacing. D is the spacing between the two openings. So D is same because we are using a same grating element. And theta is also same because we are detecting at the same position, we detect the two orders. Like we detect the fourth order and the fifth order, but at the same place. So D sine theta for the orange, how we know that the blue light has a shorter wave? This is a very like basic thing you should remember, that with your violet, indigo, blue, green, yellow, orange, and red. So red is having the longest wavelength, the electromagnetic spectrum, and violet is having a shortest. So as we move, you will find the wavelength decreases. A basic electromagnetic spectrum. So for orange, d sine theta is equals to n lambda. So for orange, I'm saying NO and lambda O. And for blue one, we write d sine theta is equals to n lambda. So for blue, I'm writing NB and the wavelength is lambda B. Because the d sine theta is same for both. Why d sine theta is same? D is a spacing between the two openings and theta is an angle. These two are, so the product will be same. So simply what I can do, I can compare them. I can say the wavelength of the orange multiplied by the order of image of orange is equals to, that is equals to the wavelength of the blue, the order of image of a blue, and the wavelength of the blue. Now we just substitute the values. The order of the orange, it was a fourth order maxima, so we put 4. All the options are in nanometers, so I don't have to convert the unit. I can just simply take 600 because final answer will be in nanometer. The order for blue light, it's a fifth order, so n is equals to 5, and lambda b we don't know. So this will be divided, so 4 multiplied by 600 divided by 5. What's the answer for this? So 4 by 5 of 600, 480. Okay. So B will be the right answer. Is it clear? Discussion 9. Question 10, any doubt? In question 10, the frequency of a vibrating mass M suspended by a spring with a spring constant of a K, where C is a constant with no unit. So C does not have a unit. What is the value for P and Q? So because if the equation is a homogeneous equation or a right equation, the units on the left-hand side and the units on the right-hand side should be same. So what is the unit of the frequency? The unit of the frequency is second inverse, or 1 over second you can also write. Hertz or 1 over second. C does not have any unit, so we don't write. M is a mass, so what is the unit of the mass? The unit of the mass is kilogram, kg, raised to power P. What about K? K is a spring constant. The unit of the spring constant is Newton per meter. But Newton per meter is not the base unit. What is the base unit? Like Newton itself equal to what? Newton is kilogram meter per second square. Like second raised to power minus 2. Divided by meter. Like this was Newton, kilogram meter second raised to power negative 2 divided by meter. So the meter will cancel with meter. So what we are left with? We are left with kilogram kg second raised to power negative 2. And what is the power here? The power is Q. Now we simplify. S is minus 1 is equals to kg raised to power P, kg raised to power Q, and second raised to power minus 2Q. If I further simplify, I can write second is minus 1. It will be kg, kilogram, P plus Q, and second raised to power minus 2Q. Now it's just a comparison because there is no kilogram on the left hand side. So it means what is the power of the kilogram? power of kilogram is 0. So we just compare the power. Here the power of kilogram is 0 and here the power of kilogram is P plus Q. So the first equation which will form, it means 0 is equals to P plus Q. That is one equation. The second equation will compare the powers of second. Here second is -1 and other one second is -2Q. Now we simplify, negative will cancel with negative. So 1 divided by 2 is equals to Q. So what is the value of the Q? The value of the Q is 1 by 2. Now how to get the value of the P? Because we have this equation that 0 is equals to P plus Q or P is equals to minus Q. And Q is equals to half, so P is equals to minus half. So what is the value of the P? The value of the P is negative half and value of the Q is positive half. That's why it matches with option B. So whenever you need the unit, whenever you want to work out the powers, so what you do, you first write them in the base unit, and after writing them in the base unit, you will compare the powers of the base units like kilogram with kilogram, second with second, meters with meter, and then you will work out by using a simultaneous equation. Is it clear? Question 10. Question 11, any doubt? Any doubt in question 11? Question 12, any doubt? Question 13. Question 12, okay. Question 12 is actually related to a projectile motion. So a projectile motion or a two-dimension motion. So the motion will have the two component, horizontal and the vertical. So if the velocity v is there, this v will have the two component. One of the component is with an angle. The component which is with an angle, what we call v cosine theta. And the other angle will be the other component will be the vertical component. So what is the vertical component? The vertical component is v sine theta. The vertical component is responsible for the maximum height, where horizontal component is responsible for the maximum range. The total time it moved from P to Q, the total time of the flight is t. And the horizontal motion in a horizontal component, the object does not accelerate because we assume that there is no air resistance, no force opposing the motion. And in the vertical plane, it will have an acceleration, a constant acceleration due to a gravity. So when we write, because when there is no acceleration, we use a formula that speed equals distance divided by time. So we need, because why we did not use the equation of the motion, because the equation of the motion is valid when the object is accelerating. So for a vertical plane, we'll use the equation of the motion. But for horizontal, we don't have to use the equation of the motion as the object is not accelerating. So the horizontal component of the speed is v cosine theta. Distance is a maximum distance, which is a range. And the total time, in the question, they gave the total time, capital T. So if I need the range, the time is divided, other side multiplied. So it will be V cosine theta times T is equals to R. So it matches with option A. That the maximum horizontal distance is a product of a horizontal component of the velocity time multiplied by the total time of the flight. Is it clear, this one? Next, we have question 13. A sound wave reduces in intensity but maintain a constant frequency as it travels through the air. So the frequency is a constant. What usually happen, the maximum displacement of the particle changes. Look, how a sound wave is produced? The sound wave is produced by a series of a compression and a rarefaction. Compression means the region where the particles are closer and they're vibrating. The particles are closer and vibrating, and same thing, a rarefaction also, particles are having a large space and they're also vibrating. But the spacing between the particles when a sound wave is produced, as a sound propagate or travel from one place to another, this position of the particles continuously changes. Like the spacing between the particle is continuously changing. As you can see here, so the spacing, as this is representing the motion of the particle, but the particles spacing is continuously changing. Here, the particles have small space, then it getting larger, and here maximum, then it decreases, start to decrease, and again minimum space is there. Then again increase. So the spacing between the particles, when it's producing a sound, it is continuously increasing and decreasing. So the question is related to the sound wave reduce the intensity. Intensity means we have reduced the loudness but maintain a constant frequency. So the maximum displacement of the particle changes between one particle to the next particle. Yeah, that is the right statement. Because if we reduce the intensity, it means we reduce the amplitude. And what is the amplitude of the sound waves? When we have these sound waves, when we define the amplitude of the sound wave, amplitude of a sound wave is a maximum spacing between the two particles. That is the amplitude. So if we, and what is the relation between the amplitude and the intensity? They are directly proportional with square. So if the amplitude is double, intensity will increases by 4. So in the question they mentioned we have reduced the intensity. So if we have reduced the intensity, it means we have reduced the amplitude. And when we have reduced the amplitude, so what will happen? The maximum displacement between the particles will also change. Why not B? The phase difference between an adjacent particle is 0. No, between the adjacent particle, the phase difference is not 0. Between the adjacent particle, the phase difference is when the particles are moving, if one particle moves towards right, the other particle will move towards left in opposite direction. And the wavelength is a distance between the two particles, have a phase difference of 180. No, the wavelength is actually because when we talk about the wavelength of the sound wave, it's a distance between the two successive compressions or the two successive rarefaction. So when we compare one compression to another, that distance is called a wavelength. Or from one center of one rarefaction to another, that is equals to one wavelength. And in a normal waves, whenever we are working out the wavelength, it's always the distance, the distance between or the spacing between the two particles which are in phase, not anti-phase. And two particles have a phase difference of a 360, have a same maximum displacement. The phase difference between the two particles, like as I mentioned here, the last statement, two particles that have a phase difference of a 3 have the same maximum displacement, means two particles which are in phase or one wavelength apart. But usually when we are talking about, we are measuring a wavelength here for a sound wave. We have here a compression is there.